Hi everyone, this is a Mechatronics project presented by a group from Section 4, which consists of two members, who is me, Siew, and Abdelrahman Taher Muhammad Asman. And our prototype is named Aquatron, which is a smart irrigation system dedicated for home agriculture with the use of solar power. In this project, we aim to develop a smart, autonomous, and self-sustainable irrigation system for any plants that our users wish to plant within their household area. And for our prototype, we focus on the implementation of solar energy as well as the interactions between sensors and actuators, such as solenoid valve. By default, the irrigation system we developed already can perform several traditional and modern irrigation methods, such as strip irrigation, basin irrigation, and surface irrigation. So overall, the project's objectives are to implement solar power as sustainable energy source of a whole system with mechanisms that maximize the efficiency, as well as implement sensors to acquire necessary real-time data, and also create a smart water valve that automatically controls the water flow according to decision made based on sensor data. For now, I will tell about the key features of our system. The first one is a solar trigger system that allows the solar panel to always face towards the direction having higher light intensity from time to time. And we are also using a microcontroller, which is Arduino Due, that acquires, processes, and analyzes data signal from sensors. And also it provides command to actuators based on the control algorithm. And also we have a variety of sensors and as a DAS, which is a data acquisition system. And we also have solenoid valve and servo motors as our actuators. And we will be using Simulink as a software platform to develop our code in the form of block diagrams. And also we can develop a user interface from Simulink for monitoring purpose. Hello guys, this is the rough overview of our prototype of smart irrigation system along with the solar tracker system. But later on, when we apply the system, this part should be connected to a inverted water tank to allow water flow downward due to the pressure of water itself. And another part, which is the pipe outlet, there should be water flowing out to irrigate your plants. And this is the actuator for our system, which is a solenoid valve. It decides whether to open or close the valve to control the fluid flow. So what's special about our prototype is that we use sustainable energy such as solar energy. And to maximize its efficiency, with our solar energy system is featured with a solar tracker as well, which we will need 4 photoresistors here to detect lights, as well as we have 2 servo motors here to allow rotation of the solar panel left and right as well as up and down. So what happens is that this solar panel will always follow the direction where it has the maximum light intensity to always receive the maximum amount of light and generate the maximum amount of electricity. Since we are using a solar panel, definitely we need to connect it to a solar charge controller. And this controller, this is where the solar panel connected, and the charge controller has to be connected to a motorcycle battery which having a voltage of 12 volt. The solar charge controller is actually the device where you can control your energy supply. So if you click this, so you can see how much the solar panel is voltage, how much voltage is the solar panel supplying to your battery. And actually you can modify it, adjust it by yourself by clicking this one. So if I want a lower one, I have to click for a long time. You want a lower volt, you can
control it freely. For now, I will just put it 12 volt as per required. As well as you can control the voltage supplied to the from the battery to your load as well, and you can control accordingly. So our battery, aside from recharging by the solar panel, it will supply voltage to our whole system as well, such as our sensors and actuators. Since we are using Arduino Duo and it only allows a maximum voltage of 5 volt, so definitely we have to use a DC-DC converter to step down the 12 volt from battery to 5 volt. But for the solenoid valve and also the relay, we don't have to do that because they have to operate under 12 volt. So there will be 2 connections. The small breadboard is the electrical circuit set up for the solar electrical system, and the data acquired by the 4 photoresistors are transmitted to the analog inputs of our Arduino Duo, which will be interpreted by the Arduino and transmit an output signal to the solar electrical system, to the servo motors of the system. Next, the Arduino Duo also acquires data from 4 different sensors, such as this is a thermistor, a temperature sensor, and then this is a humidity sensor, which measures humidity of air, as well as a soil moisture sensor, which is our main sensor for this project, because it measures the soil, the moisture level of the soil. And surely, when it is raining, depends on the level of rain. We sometimes don't have to irrigate the plants by ourselves, because the rain will irrigate for us. So definitely we need to have a raindrop sensor as well to prevent irrigate the plants while it's under heavy rain. Last but not least, this is the relay. In our application, the relay is used as a switch, where we use the PWM pin from Arduino Duo to control it, and we use the relay to control our solenoid valve. So what happens is that if the relay is tripped, then the valve is closed. So now I'm going to show how does sensors, raindrop sensor as well as the soil moisture sensor affects the decision whether the valve is closed or open. I will just use a cup of water to simulate a condition similar to 100% soil moisture as well as heavy rain, which is 100% as well. For now, I'm running it with the Simulink. I will show how does the valve close based on 2 sensors, such as the soil moisture sensors as well as raindrop sensors. So now, if let's say we are having a huge rain, so I will try to demo it using this one. I will rinse the sensors into a water, full of water. By this way, the solenoid valve should be closing, as shown here. So you can see if the valve is closed, there will be no water coming out from the pipe connected to the valve outlet. But what happens is, if there is no rain, so first of all you can hear a clicking sound, a trick sound from the relay, and now the valve is opening. And I will show again for the soil moisture sensor. If you pour some water inside the pipe, by right the valve should be open, so there will be water flow from the pipe outlet. Let's try it. Alright, so now I will direct the pipe downward and see what happens. So you can see there are water flowing down, right? What if I put this inside to simulate 100% soil moisture. It stops, right? There's no longer water pouring out.
So now I'll be telling the benefits of our product. First of all, of course, the system is fully automatic, so the users are not really required to turn on and off the valve by their own. And also, we use sustainable energy. So basically, the system is self-sustainable as it uses renewable energy such as solar energy. And also, since the system will be able to always capture the maximum amount of solar energy to be converted to electrical energy, so it is a very efficient system. And the presence of Arduino 2A provides a quick response for the sensors as well as the actuators, typically on the processing of data. And we also have a user interface to ease monitoring by users. But of course, everything has two sides. For um, our system will have potential drawbacks as well, such as oversensitive actuators. Because in simulating the sampling time of each sensors and the motors and solenoid valves are quite frequent. So probably like zero point 0.1 or 0.01 second. And also the sensors will give different output once a critical threshold value is reached. Let's say if U1 is less than 40%, then you give 0, and then U1 is greater than 40%, then you give 1. So if the value of sensors fluctuates between, probably the actuators will develop some undesired fluctuations in respective motion as well. And also, since the system is fully automatic, we don't possess a way to force the operation to stop, especially on the solenoid valve, unless you cut off the power source of the Arduino Due. And then, if the sensors are broken, we the only way we can fix it is to replace the sensors. So we have many connecting components such as jumper wires and multi-core wires. And if one of them is faulty, then the whole system might be affected. So this is a problem as well because it's hard for you to check which wire is broken. And for the user interface, it has a disadvantage which that it must be connected to laptop to so that the user can monitor the system. This is our system architecture. Yeah, you can pause to check for it. And then this is the user interface we developed in Simulink. And from this user interface, the two small block named as solar tracker system and the sensors and relay are our block diagram in Simulink, which is the hardcore, the core part of our coding. But for this user interface, it is for the purpose of monitoring. For the software part of our system, this is a Simulink block diagram that works behind our system. For the bottom part, it is the block diagram for the sensors and relay. And the upper one is the block diagram for our solar tracker system. And then let's take a look. So as you can see, this is for humidity sensor and which is connected to the anode pin of Arduino. And these are the necessary calibration that we have to make so that the sensors will display the value we desire. The value given by our humidity sensor is U1. If U1 is less than U2, then it should be giving a value of 1. Otherwise, um, it will give a value of 0. So, we implemented logic gates to combine the outputs of those if-else statements. So, for between humidity sensors and the raindrop sensor, we use a OR gate. So, if either of them are putting 1, the output will be 1. Only the output is only 0 when both of them give 0. But for the humidity sensor as well, sorry, for the random sensor and the soil moisture sensor, their results are combined using an AND gate, where the output signal will only be 1 when both of them are giving output signal of 1. And I'm using an AND gate for to combine the both logic gates here as well. And the output of This second AND gate will be nominated as U1 again, and it will decide the PWM output of for the relay. So if U1 is equals to 1, then you'll be giving 0 to the relay. Otherwise, if U1 is 0, then 255 is given to the relay, which is connected to the PWM pin 10 of your Arduino. So for instance, if it is not raining at all and the soil is completely dry, even if the humidity value is greater than the threshold value, which means the humidity level is optimum, um, then since the humidity level is optimal, this one will be receiving the value of 0. But since it's raining heavily, so this is 1, and we have no soil moisture yet. The soil is very dry, so this is 1 as well. So since this is an AND gate, it will be outputting 1, and the OR gate will receive 0 and 1, so it will output 1 as well. So since this is an AND gate, then the final output will be 1. So if the U1 is equal to 1, definitely it will give 0 to the relay. So that means the relay should open the valve to irrigate the plant.
Okay, so this is the algorithm inside of Simulink for the solar tracking solar panel. Here we have four different inputs from the four photoresistors. Then these inputs are getting analyzed and using different if conditions. For example, here if top right is more, top left is more than top right, this certain this if action will occur, and so on. And the same thing goes for the all of the eight different conditions. Um, these conditions affect the two different servos. This servo here, this servo here uh, manipulates the movement of the solar panel in the X, Y plane, and this one manipulates it in the Z axis, going up and down, and here it's right and left. So if action works in this manner, you have the input, which is originally always 0, it goes, it gets saved in the memory, and depending on the condition, it will either plus or minus the angle from the servo. So if it's plus, it will go to the right, negative, it will go to the left, and so, and this value will keep changing because the value of the value coming from the photoresistors keep changing depending on the light intensity. And that's it. Thank you.
Then the next one is technology sustainability. At this point, I believe you already know the reason why our system can be considered as technologically sustainable because we utilize solar energy as source of electrical energy that are supplied to all components involved. And since we are using coding Simulink, so and also a lot of electronic components, basically we can reduce our labor force and as well as the mechanical solutions involved in the irrigation system, so that we can produce less pollution because normally the mechanical solutions, one of the disadvantage is they often produce pollution. So now let's head into the conclusion where our system that is developed for convenient and smart home agriculture. And since we use solar energy, so our system is environmental friendly and it is self-sustainable as well. And it has a solar system to maximize the efficiency of solar energy capture. So no worry about when the weather is cloudy because our panel will find a way to generate the most electricity. And also, if you worry about the consistent voltage supply, we also have a solar charge controller to regulate the voltage. So there's no worry about that. And then the system has a complete data acquisition system with four different sensors as well as a photoresistors as well to process the data and transmit signal to our actuators. So it is fully automatic and precise. So thank you for your attention. That's all from me.